Daniell cell is an example of galvanic cell in which the metal is immersed in its own salt solution. That is, it is a combination of two half cells. This is one of the half cell and this is the other half cell. A half cell consists of an electrode and an electrolyte. So here the electrode in Daniell cell, one of the half cell, the electrode is zinc and the electrolyte is zinc sulfate solution. And in the other one it is copper and copper sulfate solution. Now these are connected using a metal wire. Now this zinc is the anode here and oxidation takes place there. Zinc has got higher oxidation potential and hence oxidation takes place here. Whereas in the case of copper, the place where copper is immersed, it acts as the cathode and there reduction takes place. Now anode is usually positive, that is, these anions are the ones that travel towards the anode and anions are negative. So negative travel towards the positive and you could say anode are usually positive and cathode is the negative one. Now here the oxidation takes place and zinc, it is a loss of electron oxidation. So zinc becomes Zn2 plus 2 electrons. Now here in this case, zinc becomes Zn2 plus 2 electrons, so that here in the salt solution, zinc becomes Zn2 plus and the other one becomes SO4 2 minus. Now when zinc metal becomes Zn2 plus 2 electrons, there is a higher amount of Zn2 plus and that will repel. Since anode is positive and Zn2 plus is also positive, they will repel and the Zn2 plus will come to the solution. Whereas the 2 electrons, that is, for every Zn2 plus there is double number of electrons. These 2 electrons, since they are negative, the anode is positive, so they will attract or accumulate on the anode. And that is the reason why anode act as a negative pole, because these electrons are accumulating on the anode. And just this way, on the cathode, reduction takes place of copper, that is Cu2 plus 2 electrons gives the copper metal. Here there is Cu2 plus and SO4 2 minus and this copper metal is formed by reduction, that is 2 electrons are adding to the Cu2 plus to give Cu. So there is a higher number, the number of copper here, Cu2 plus, the number of Cu2 plus ions becomes lesser. So the reduction is taking place. So the amount decreases over time and SO4 2 minus, the amount of SO4 2 minus increases. And the Cu2 plus, since cathode is a negative one, the Cu2 plus will accumulate on the cathode which is negative, and that is the reason why cathode act as a positive pole. Now here the amount of Zn2 plus goes on increasing and Zn2 plus, the amount is greater here, and you could say the solution will act as a positive solution. And here in this case, the Cu2 plus goes on decreasing because every Cu2 plus it gets added with 2 electrons to give Cu. So the Cu2 plus amount is decreasing and SO4 2 minus amount increases and hence it will act as a negative solution. Now the overall equation. This is the equation of oxidation half cell and this is the equation of reduction half cell. And let's consider the overall equation. Here Zn and here Cu2 plus 2 electrons. So this is the left hand side and all of this gives Zn2 plus Cu and here there is 2 electrons. So this is the overall equation, and in this equation the 2 electrons get cancelled and you could say here there is an oxidation part in which Zn, the loss of electron, Zn becomes Zn2 plus, and there is a reduction part in which Cu2 plus gives Cu. And together, if it comes together, you could say it is a redox reaction. A reaction in which oxidation half cell, a half cell is there and there is a reduction half cell. Oxidation and reduction takes place simultaneously. Now, you could see a salt bridge here. This salt bridge contains strong electrolytes. Salt bridge contains strong electrolytes. Strong electrolytes, example KCl or KNO3. These KCl in the strong electrolytes, the use of them are here, as I said, there is a larger number of Zn2+, so it is a positive solution. There is a problem with it being a positive solution. That is, again, here oxidation takes place, so Zn2+ is goes on increasing the number. So it will repel or it will show a tendency to stop the reaction as there is more number of positives, so it will not add again positive to it and the reaction may stop. And here also the number of Cu2 plus SO4 2 minus is more. So this is a negative solution, and you could say through metal wire the electrons travel from the more positive travels from the place where there is more to the place where there is less. So when electrons come towards here it is negative, already it is a negative solution, so more number of electrons, the chance of more number of electrons coming towards to the negative solution decreases and there could be a chance for the reaction to stop. So when we add KCl in the salt bridge, it actually maintains the electrical neutrality between two half cells. That is, here Zn2+ is more. So let's consider the salt bridge and strong electrolyte to be KCl. So here there is KCl and Zn2+ is more. The Cl minus will come towards here and it will balance the electrical neutrality, that is Zn, it becomes ZnCl2 and balances the positive solution so that there is an electrical neutrality maintained in these two half cells. This is the reason why salt bridge is added, so that it brings about an electrical neutrality between the two half cells and the reaction does not stop.